If you fell into a black hole, you wouldn't be crushed first. You wouldn't scream. You would watch the universe end and fast forward. Because inside a black hole, time doesn't just slow down. It breaks. Black holes are not cosmic vacuum cleaners. They don't roam the universe, destroying everything. But they do something far stranger. They bend time, trap light, erase information, and force physics itself to admit it doesn't have all the answers. In the next few minutes, we'll see what really happens near a black hole, what happens to time, and why falling into one would change your reality forever. For centuries, humans believed space was calm and eternal. But black holes shatter that idea. They prove the universe has places where the rules don't just bend. They fail. Black holes are not just objects. They are warnings. A black hole forms when gravity wins completely. When a massive star runs out of fuel, there's nothing left to hold it up. The core collapses, matter is crushed inward, and space itself caves in. The result is an object so dense that not even light can escape. That invisible boundary is called the event horizon. Once you cross it, there is no return, not because something pulls you back, but because all possible paths lead deeper inside. To understand how extreme this is, imagine compressing the entire Earth into the size of a coin. That's what a black hole does to matter. Time is not constant. Einstein showed us that gravity bends time itself. The stronger the gravity, the slower time moves. Near a black hole, gravity becomes so intense that time nearly stops. If someone watched you fall toward a black hole from far away, they would never see you cross the event horizon. You would appear to slow down, freeze, and fade away. But from your point of view, everything outside speeds up. GPS satellites already experience this effect. Their clocks tick faster than clocks on Earth. Without correcting for time dilation, your phone would be wrong by kilometers. Near a black hole, this effect becomes infinite. Time doesn't slow smoothly. It fractures. Stars age. Galaxies evolve. The universe rushes forward. In seconds, you might witness millions of years pass outside. This isn't science fiction. This is what our equations predict. A black hole isn't just a place in space. It's a place where time stops behaving like time. As you fall, the sky changes. Light bends. Stars distort. The universe folds into a glowing ring above you. This is called gravitational lensing. You would see behind yourself. The universe would curve into a sphere of light. Despite what movies show, black holes do not suck. If our sun were replaced by a black hole of the same mass, Earth would keep orbiting exactly the same way. The danger isn't distance. The danger is proximity. Get too close, and gravity becomes uneven. Your feet are pulled harder than your head. This effect is called spaghettification, not because it's funny, but because objects are stretched into long, thin shapes. But here's the twist. If the black hole is massive enough, you could cross the event horizon without feeling anything at all. No alarm, no pain, no warning. Inside the event horizon, space and time swap roles. Moving forward in time becomes as inevitable as falling downward. You cannot stop. You cannot turn back. Every possible future leads to the center. At the core lies the singularity, a point where density becomes infinite, and our laws of physics collapse. Here, equations stop working, time loses meaning, and information may be destroyed. This creates one of the biggest problems in modern physics, the black hole information paradox. If information is lost forever, then a universe is not predictable. Physics is built on one assumption. Information is never destroyed. Black holes challenge that assumption. If information dies, the universe forgets its own past. And a universe that forgets cannot be predicted. Even today, no one knows the final answer. Black holes may not be destroyers. They may be teachers. They force us to confront the limits of reality. Some theories suggest information is stored on the event horizon. Others suggest black holes could connect to new universes, or that time itself is an illusion created by gravity. Stephen Hawking once said, "Black holes are not eternal. They slowly evaporate. Even the darkest objects in the universe eventually disappear," which means black holes are not the end of everything. They are part of a larger story we are only beginning to understand. Every major theory breaks near a black hole. General relativity fails. Quantum mechanics fails. That's why physicists believe the answer to everything lies here, not in stars, not in galaxies, but in the darkest places of reality. Every major theory breaks near a black hole. General relativity fails. Quantum mechanics fails. That's why physicists believe the answer to everything lies here, not in stars, not in galaxies, but in the darkest places of reality. A black hole isn't a monster in space. It doesn't hunt. It doesn't hate. It simply obeys gravity to its absolute limit. And in doing so, it shows us something uncomfortable, that space, time, and reality are far stranger than our intuition allows. The universe is not built for human understanding, and black holes are its deepest reminder. Inside a black hole, time doesn't die. It never existed the way we thought it did. Black holes are not enemies. They don't threaten Earth. They don't hunt us, but they quietly remind us that reality does not care what we expect. And that time, the thing we trust most may not exist at all.